Thanks, BJ. You guys might notice he's also wearing the Ride Tech shirt. He is the general manager of Ride Tech, so if you need to tell us how good a job we're doing, that'd be my department. If you have any complaints, please see BJ. Ride Tech is the name of our company. Some of you might be more familiar with us for the last 17 years under the name of HRIA Technologies. We changed company names about 4 or 5 years ago, I guess it was. The main reason for that wasn't ownership change, wasn't employee change. It was actually more product change. Over the years, we had obviously started out back in '96 as primarily air suspensions, where we got our start. And then that evolved into sway bars, 4 links, bolt-in roll cage systems, coilover systems, shock absorbers, just hot rod suspension in general. So that necessitated the need to change the name to Ride Tech. No other changes were done. Same people own it, same people work there, same buildings. The only thing that changed was the letters on the catalog. This pretty much states it all. We are hot rodders. Virtually everyone that works in our company has a hot rod. I myself own a 70 Chevelle. The owner of the company, Brett, has about 20 or 30 hot rods. He's actually this weekend racing out at the inaugural USCA event in Laguna Seca. That's what makes our parts better. Using them, installing them, abusing them, it all leads to a better product for the rest of the hot rodders. We are based out of Jasper, Indiana, a group of about 40 enthusiasts. We do virtually all fabrication in-house. We do all CNC tubing bending, CNC machining, welding, all of our control arms, 4 links, roll cages, everything is built in-house. We do all research and development in-house. We have a couple full-time engineers devoting to just designing new product. Like I said, all the manufacturing, TIG welding. We do a lot of bolt-in roll cages and stainless steel 4 links that all get TIG welded. Most everything else is MIG welded. And one of the things, the main thing to remember when it comes to buying parts for your car is you don't want to buy just individual pieces of a car. You don't want to just buy a control arm from this company and another control arm from this company and a shock from this company. What we're after is making a complete system that all works together. You don't have any interference issues, and everything works in harmony. Like I said earlier, we do air suspensions and coil sprung suspensions these days too. So keep this in mind for all of your suspension needs, not just air suspension anymore. Main 2 types of springs. Obviously the spring is the heart of your suspension. You have coil springs. We use all Hyperco springs. They are all CNC cold wound springs made in Indiana. Some of them are made down in Louisiana, but they're all made in the U.S. Very high tensile strength steel and high silica content. The best springs out there. I think every IndyCar race won since 1970 has been won on Hyperco springs. A good quality spring go a long way. They're guaranteed not to take a set. The most difficult part about selecting a coil spring for your application is selecting the spring rate. To accurately calculate the spring rate, first you need to know the vehicle weights, corner weights, and then we also need to look at the unsprung weight of the car. The unsprung weight would be your lower control arms, the spindle, the wheel, the tire, all the things that the spring is not holding up. On most cars, for any independent front suspension, you're going to be looking around 125 pounds of unsprung weight that the spring is not lifting. For a rear suspension, you got the axle, the 4-link, the leaf springs, all again unsprung weight. When looking at the spring rate of a independent suspension, you also have to calculate in your motion ratio. Think of your lower control arm as a lever arm. If you were to measure from the center of the pivot point out to the center of the ball joint, and then take the measurement from the pivot point of the frame out to where the shock mounts the lower control arm, that will change the leverage ratio. If that shock is mounted way out by the ball joint, you may be able to get away with, for example, a 300-pound spring rate. If it's mounted dead in the center, you got a 2-to-1 leverage ratio. You might need a 700 or 800-pound spring on the exact same weight vehicle. So that's a very important part. Most of this information we've already collected. If it's a first-gen Camaro, Mustang 2, Chevelle, Nova, any of the normal applications, we have all this information. We don't have to take that for us. But if you do have a custom application, custom control arms that you've manufactured yourself, we can take some simple measurements on your vehicle and help you select the proper spring rate for it. The angle that the shock or spring is mounted at also plays into that configuration. You typically don't see a whole lot of angle on a front suspension, but on a rear suspension, we do typically mount them. Usually around 22 degrees is an optimal angle for your rear coilovers to be mounted at. And if that shock is straight up and down versus at a 25-degree angle, that can actually change your spring rate by a spring or two. If you get over closer to a 45-degree angle, that can greatly affect the spring rate needed for that application. So a simple angle finder will help you find out what your spring angle is on the coilover or whatever it may be. The last part in selecting the proper coilovers or the proper shocks and springs for your car is the dimensions of the shock absorber. On a rear coilover application like this, you would simply want to measure your ride height dimension. Ride height is the most important dimension. What we're after is you want to run that shock absorber between 40 and 60% stroke of the shock when the car is at ride height. So if you have a shock that compresses at 11.5 and extends at 16.5, then you want to drive it around 14.5 inches in that range. The longer the shock absorber, the better off you're going to be. The more wheel travel you can use, the lighter spring rate you can get away with because you have more compression and rebound travel available. So anytime you are, especially on a lot of these rear street ride applications, you might have multiple holes on your axle brackets. I'll usually shoot for the bottom hole on those. That'll allow us to get a longer shock absorber in it, better ride quality. Probably one of the biggest mistakes on building a hot rod is a guy will end up with a very short shock absorber, a short 10 or 11 inch ride height on the rear, and then you end up using a 3 or 4 inch travel shock on it, and it just isn't enough travel. Rule of thumb, I like to keep at least 5 inches of suspension travel out of any given vehicle. If anybody's got any questions along the way, please raise your hand and I'll be happy to answer them. One quick and easy way to help you, once you've collected all these measurements, to help you calculate the actual spring rate is we have developed a spring rate calculator. This is available on our website. We also have iPhone and Droid applications for your smartphone. Especially if you're a dealer and you're actually doing this stuff a lot, having that iPhone app is kind of handy. You can actually download angle finders on your smartphones as well, so you can calculate your spring rate right there under the car without grabbing any tools. So. Air springs is a very similar product as a coil spring. You got to remember the car doesn't know what type of spring it is, whether it is an air spring, airbag, air spring, all the same terminology, or a coil spring. They do the exact same thing. Different air springs, be it a double convoluted bag or a sleeve style bag, they all have different spring rate characteristics to them. Some are more linear, some are more progressive. You got to look at what will actually fit in that application and whether it's going to lift it with the amount of pressure that you have available. They've been used for the last 30 years plus in OE, especially semis. Any vehicle that's going to see a lot of varying loads, air springs have a huge advantage there. When you have a customer that's wanting to build a car and this customer asks you, should we do coilovers or should we do air suspension on it? That's probably one of the most common questions we do get. And for our industry, obviously air suspensions have tons of advantages, be it the ride quality, the adjustability, the ability to offset for different loads. But in our industry, most of those customers want air suspension because of the adjustability. Being able to get that ultra-low show stance and still get it back up high enough to drive it. So to me, that's the biggest thing. I mean, we can, with the shock technology that we have, be it air springs or coilovers. It's the same shocks, the same control arms, the same spindles, the same forelinks. You get very similar, assuming you get the right spring rate on the car, you can get very similar results in the ride quality and the handling with an air spring or a coil spring. You got to look at the budget. Obviously, an air suspension is going to be a little bit more money because you got the compressor, the tank, the valves, all that stuff. But like I said, it just comes down to what that customer's goals are in mind. You might be able to accomplish those same goals with a coilover system that you can with an air suspension for what his needs are and save the guy some money. So, but again, if he's after that ultra low show stance, air suspension is the only way to get that. We have all different types of air springs. You can see there, and all these different types of air springs have different load capacities, different minimum heights, different installed heights, different extended heights. We use all Firestone air springs, and they probably have 800 different types of air springs. We've selected, here's a chart of probably the 10 most common that you'll use in this industry. So you can find all this information in the catalog I handed you and on our website. What's great is for most applications, we've actually got kits developed for it already. So if you got a 55 Chevy or a 61 Cadillac, we got kits specifically for that. So you don't need to know all of this information. We have it all available for you. We've already done all the fitment on it, manufactured brackets for those applications to make it much easier to you. I mean, you can just start looking at some of these prices of just an individual air spring, and then you look at the price of a complete system. And if you've ever designed your own air spring setup, you'll understand why the price difference is there. All those brackets and stuff make the installation so much easier and trouble-free. Just like any shock absorber or spring, you want to, with an air spring, you need to have it about 40 to 60% travel of the air spring. If you drive it too low, the suspension is going to bottom out and it's not going to ride very well. If you drive it too high, the shock absorber is going to top out and it's not going to ride very well. So you always have to make sure that your idea of the designed ride height and your customer's idea of the designed ride height are the same thing. And especially when doing air spring and separate shock setups, you need to make sure that if the shock absorber is at its designed ride height, that the air spring is also at its designed ride height at the same time. They got to be working together.
What do you typically recommend customers set the ride height for?
Well, ride height is very much an opinion. Every customer's got a different design, different idea of what the ride height should be of that particular car. Most of our suspension systems, we set them up to run about 2 inches lower than factory. That will allow you about 3 inches of compression travel and about 2 inches of rebound travel to make sure that as you hit a bump, you don't bottom out and you don't top out. So it's got to be right in that mid travel. That is designed in the air. If it's an air spring setup, it's designed in the brackets. They'll usually do a cup bracket or a plate or whatever to attach the air spring to the control arms in the frame, and all that is designed into the brackets when you do it. So now, if a customer's got a different ride height in mind than what we have designed for that vehicle, it's not out of the realm to redesign those brackets to achieve that new designed ride height. So
You go in with your design and go and customize the ride height.
yeah, maybe customize the brackets, put a spacer into the bracket, make sure the shocks, and that's where you have the car aligned at. Now, you're right, as you deflate the car, your alignment is going to, your caster, camber, toe, it all is out of whack. But the key is you're not going to drive the car fully deflated. You're going to drive it at ride height. And as long as you drive it at ride height, your alignment will be set perfect. So to achieve ride height, we'll talk about that here in a little bit. There's a few different methods of attaining ride height, and some are more accurate than others. Air springs are a very, very tough product. They don't fail. 99% of the time that we see an air spring that someone claims has failed, it was due to installation error. They cannot take abrasion. These air springs are very thick. You guys can come up and look at these later. They're built like a tire. There's nylon cords inside of it, so they last millions and millions of miles. It's usually due to installation error. The air springs rubbing against the bracket, the air springs being overextended or bottomed out. Some air springs you can allow. This particular double convoluted air spring, you can allow it to bottom out. You do not need an external compression stop. When you get to a sleeve style air spring, then you do need an external compression stop because it would damage the air spring if you let it bottom out. Yep. Thanks, Peach. Sleeve style air springs like this one's actually set up on a shockwave design, so it's actually set up with machine to take a shock inside the air spring. A sleeve type bag actually has crimp bands around it to fasten it to the piston and to the top cap. If you overextend the air spring, it can pull the rubber out from under that band. So to keep it from overextending, we use the shock absorber. The shock absorber is what's going to keep that airbag from overextending, and then an external compression stop between the axle and the frame, or between the control arm and the frame, is what would keep it from bottoming out. So double convoluted bags almost can't hurt them. You can hang that car upside down by a double convoluted air spring without pulling it apart. Sleeve style air springs are a little bit more vulnerable. You got to make sure you install them right. Why do we use sleeve bags? They have more of a linear spring rate. The double convoluted bags have more progressive spring rate. So as a general rule of thumb, you will use a double convoluted air spring on a front independent application, and a sleeve bag will be used on a rear application. The sleeve bags have more travel as well, so you get a little bit better ride, especially when you're in a 1-to-1 motion ratio rear suspension. Well, you can't measure spring rate directly. You got to look at the spring characteristic more than the physical rate. What I mean when a sleeve bag is more linear, as you compress it, it takes 200 pounds for the first inch, 200 pounds more for the second inch, whereas a double convoluted bag, it's 200 pounds for the first inch, maybe 500 pounds for the second inch, so it's progressively more. And there's different size air springs. The load capacity air spring is probably more relevant to the spring rate. Yeah. The sleeve bags are a very linear spring rate. Yeah, they're almost completely linear, and you can actually change how linear it is. This has got a straight piston on the bottom that it rolls over. You'll see on some OEM type springs and some of the ones that we use where the bottom piston's actually tapered, and that taper to it can actually make it a little bit more progressive if you so wish it to. They can even put a back angle tapered the opposite direction, which can almost get into a digressive spring rate too. So for optimal ride quality, but it's all built around application. You know, you got to remember in the hot rod industry, things have to be a little bit more universal too because they're used on such a wide range of parts. But control systems, first in that is going to be the air compressor. We typically do not use engine-driven compressors. They're very difficult to set up. They are not maintenance free. You have to oil them. They're very difficult to hook up to the engine with brackets and all that stuff. So we just use 12-volt compressors. They're fairly quiet. You can mount them under the vehicle. They're all waterproof connectors on them and everything. Thomas is the primary compressor that we use. It is made in Louisiana. It's a U.S.-made compressor. We use almost all American-made parts, damn near everywhere we can. So the next part would be the valve block itself. This is what they refer to as a manifold-style valve block, being that all 8 valves are on one solid aluminum block. This eliminates many, many connections. If you can imagine having 8 separate valves and all the fittings in between them and the plumbing in between them, that's the key with air suspension, is trying to make it as leak-free as possible, because when an air suspension has a lot of air leaks in it, it becomes a pain in the butt and no one wants to drive the car. So these valves are rated as bubble tight, meaning that they have a 0% acceptable leakage rate. A lot of the cheaper valves you'll see out there actually have acceptable leakage rates. And they don't like moisture well. This valve is specifically made for the automotive industry. We don't even use dryers on the systems because the valve doesn't hurt, the moisture doesn't hurt anything. It just passes through the system. Everything's anodized, plated on the inside, so moisture doesn't affect it one bit. Air tanks, we switched about 7 or 8 years ago to all aluminum air tanks versus steel tanks. Steel tanks, obviously there's going to be moisture in the system. Anytime you have compressed air, there's going to be some moisture. And with a steel tank, you just can't get the inside of the tank coated well enough to make it last very long. And then eventually that rust will start to collect in the valves and things like that and start to cause valve sticking problems. So we use all aluminum air tanks in everything we do. Airlines and fittings, we use all DOT approved airlines and fittings. Same stuff they use on semi-trucks for the air brakes. Very good quality stuff, very chemical resistant, very abrasion resistant. You just want to make sure that when you are putting it together that you get a good straight cut on the airline, and they're a very simple push to connect style fitting. You just push them in and pull the collar out. I got some up here, you guys, if anybody wants to look at those a little bit closer. Obviously, this would be the most economic way to inflate an air spring. Simple Schrader valve, couple fittings, airline, done. Obviously, you lose almost all the advantages of an air suspension by not having an onboard compressor kit. You can't adjust it on the fly. You can't adjust it for offsetting loads. The only advantage you're still gaining is the ride quality. But for the amount of money you stick in an air suspension, if you don't put an onboard compressor system on it, you're almost wasting your money. Two different types of controls we use. You can do a simple analog control panel, or you can do a digital controller. This digital controller, I think we talk about it a little bit in a minute. Airlines and tank sizes. Tank sizes, the goal when choosing a tank size is to make sure that you have enough air on demand to lift that car up from deflated up to ride height in one shot. You can put, multiple 5-gallon tanks on any car if you want, but most, at least in our industry, most of those cars don't have that much room, so its minimum tank size is usually what's requested. Usually a 3-gallon tank would be a minimum tank size on most cars for a 4-way system. All that, like I said, some of the bigger cars and pallets, things like that, will use a 5-gallon tank on them, but for most lighter street rides, a 3-gallon tank is all you need on the car. So, yes, sir. Yeah, and that's important because a lot of people look at those compressors and they're like, wow, it takes 5 to 7 minutes to fill that tank up, because that's your initial fill time from 0 PSI all the way up to 150. But what you need to remember, assuming you don't have any leaks in the system anywhere, when you get to the car, you're going to have 150 PSI in the tank waiting for you. So that will lift the car up. Even with 1/4-inch lines and a 3-gallon tank, you can lift up most cars in 4 or 5 seconds. The recovery time at that point will depend on how much the tank pressure drops, but usually the tank pressure will drop to 120 or so to lift the car up, and then it's about a 2-minute recovery time in most applications. So,
why is the car falling down?
if it is doing that, then you have a leak somewhere.
Well, if you have a line leak,
Mm-hmm.
you're going to have your
Yep.
You don't have a valve.
The question was brought up that if you have a leak in the system somewhere, why would it cause the whole car to leak down? And is there a solution for that? Is there a check valves you can put in the line or anything like that? One of the things you have to remember, obviously the tank is feeding the air valve with your supply air, and then that air is distributed to the 4 individual air springs from there, 4 separate airlines. So if you get a leak between the valve and the air spring, only that one air spring will leak down. There is no way to put a check valve in there. If you were to put a check valve in that line, then you would not be able to deflate the air out of that bag. There's only one line going to each air spring, so you can't put a deflate line there. The biggest piece of advice I can give you there is do a good job on the installation. Make sure that the airlines are not going to rub. If you run the airline through a frame rail or through the floor pan, use a rubber grommet or a protective sleeve of some sort, and use Teflon tape on the fittings, and make sure you don't get close to heat. Make sure you're staying away from the headers and things with it, especially on the front suspension, and you will not ever have a problem. The best thing you can do is just take the time on the installation and make sure you never have a problem. Now, if you are in a situation where you see all 4 air springs leaking down overnight, that is likely due to you losing tank pressure. And you would know that because when you get in the car the next day, you can't lift it up right away. You got to sit there and wait 5 to 7 minutes for the tank to fill up. So yes, if you're losing it, the way these valves work is it actually requires tank pressure to hold the valves closed. So if you lose tank pressure, then all the airbags would leak down as well. And yes, you can put a check valve in there as well. And actually, that's something we started doing here not long ago, is putting a check valve. You can put a check valve. Actually, I got some you can screw right into the valve block where the airline from the tank goes into the valve block. You can put a check valve right there so that if you do lose tank pressure, that the airbag pressure won't leak down. But in reality, what we need to do is get some soapy water out and spray down all the fittings, find the leak, and fix it, and that'll resolve the problem. You should be able to let that car sit for 6 months to a year and come back and still have a full tank of air. Like I said, the valves are considered bubble tight, 0% leakage rate. The airlines and fittings do not leak. They are the best airlines and fittings you can buy. So it's fixable. One of the things you can do to help troubleshoot your leak is, say for example, you do have your right front air spring leaking. Take that airline where it plugs into the valve block and swap it with your left front. See if that leak follows the air spring or if it followed the valve. You can use process of elimination like that to narrow it down to 1 or 2 fittings. You know, that way you can tell if it's at the valve, if it's at the gauges, or if the leak is actually at the air spring itself. And that'll narrow it down to 1 or 2 fittings that way to help you find that leak. Airline size. You can get crazy with airline size. We got up to 1/2-inch airlines available. We use 1/4-inch airline on virtually everything. The only thing we'd use 1/8-inch airline is running up to the analog gauges. You got to run a small 1/8-inch airline up to the gauges. 1/4-inch airline will lift that car up in 3 to 5 seconds. Plenty quick for, like I said, in the hot rod industry. Some of the mini trucks, and you get into some of the big cruisers and pallets and stuff like that. And some of those guys, you like using the bigger 3/8 or 1/2-inch line, but the biggest complaint I get is people do install one of those systems, and then the next question is, how do I slow it down? It's so fast that I cannot even adjust it to the pressure I want. So you got to make sure you really want that, and they're a lot harder to route the airlines as well. Routing a 3/8 and 1/2-inch line, they don't bend as tight. You typically got to start cutting the car up a little bit more to get the stuff through there. So I think everyone in this room, for at least most of their projects, you'll just be using 1/4-inch airline. We talked about troubleshooting leaks a little bit already. We do have some tubing cutters available to help you get a good straight cut. The way these fittings work is it actually has an O-ring inside the fitting to seal to the outside diameter of the airline. So if you do get in a situation where that fitting keeps leaking, I've seen it before where that airline might have a scratch down it from pulling it through the chassis. And if you get a long scratch down the length of the airline, then it won't seal in that O-ring. So sometimes you just got to cut it back a little bit further. And try to get it sealed up that way. The bubble solution, little kids, works well. It's a little bit thicker than standard soapy water to help find leaks, so that's a good tip. 2-way systems versus 4-way systems. A 2-way system, you're basically using 4 valves, 2 inflate valves, 2 deflate valves. One set of valves that controls the front air springs, one set of valves would control the rear air springs. We do not recommend doing this, and we seldom even give you that opportunity when you're purchasing a kit. The problem with that is as you go around a corner, the air can actually transfer from one air spring to another. Makes it feel like you don't have a sway bar on the car. If you don't have a sway bar on the car, it feels pretty crappy. So 4-way systems on everything. You do not want to do 2-way. Here's your user interface. Like I said earlier, the cheapest would be the simple Schrader valve. We can do an analog gauge setup. That's a 2-way analog gauge. We do have 4-way analog gauge setups. It'd be 2 dual needle gauges, and then the 4 electric rocker switches. And then the best would be the digital controller. The digital controller, you have tank pressure. You can see at the top, there's a menu to scroll through the different menu options. You can inflate the air springs manually with the 4 different corners with the plus and minus buttons on the side. And then you have 3 different presets at the bottom of the screen. Typically, we'd set 1 for deflated, 2 for ride height, 3 for fully inflated. Those presets can be achieved 2 different ways. If you'll notice back on this other slide again, you have the air pressure readings at each corner. And then we also have the option to put height sensors on these cars, and that's what the bar graph represents, is the actual height sensor reading. Air pressure-based systems work fairly well. With an air pressure-based system, you're basically using air pressure to try to estimate what vehicle height should be. And it depends on the car. If you don't have a lot of varying loads, they can work pretty good on air pressure alone. But if you have a lot of varying loads, even though you go back to that same pressure every time, the vehicle height may not be correct. Also, suspension bind can lead to it not being 100% accurate every time. Usually a pressure-based system will get you within plus or minus a half an inch of the desired ride height, sometimes more accurate, sometimes less. So that's why we have actual height sensors available. And there's the height sensor. I got one up here if you guys want to see it later, but it simply mounts the chassis. You have linkage that will go down and attach to the control arm, or to the axle or to the forelink, whatever you want to attach it to, really doesn't matter. And then it just simply puts out a 0 to 5 volt signal that the computer turns into your bar graph reading. And then the computer can then it'll actually use air pressure and the height sensor to most accurately level the car out. There are some systems out there that use only height sensors, and those also do not work as well as a system that uses both air pressure and height. A height-based only system, the problems we've had with our testing and doing those, you can get into a cross-loading situation. The car may sit perfectly level, but you have dramatically higher pressures in 2 cross corners and dramatically lower pressure in the other 2 corners. And the chassis is stiff enough to where the car will still sit level, but obviously your spring rates aren't the same from left to right. And with this, we can actually level it off of that and then make sure that the air pressures are somewhat level as well, to make sure that the spring rates are equal on all 4 corners, because if you are at least on from left to right, because you can get some pretty weird feelings when you have dramatically different air pressures from one corner to another. Car definitely doesn't react the way that you would think it should. Yes. Yep. When you first fire our display up, it'll actually give you a 0 to 5 volt reading directly from the height sensor. And what you really want to make sure is, when you're setting the height sensor up, it doesn't have to be perfectly in the middle of the swing of that 5 volt swing, and you only really need about 2 degrees or 2 volts of that swing is really all you need to make the system perform properly, to get enough resolution out of the sensor. So you want to look at it at full max and all the way up. All the way up and all the way down, and make sure that at those 2 extremes that you are not maxing out the sensor. There are times where we will actually need to, let me go back to that especially on an independent front end, this sensor has about 6 inches of swing from one way to another. There's actually little tabs on the sensor right here that shows you where neutral is on it, and then you got 45 degrees either direction. So on a rear suspension, you can mount the sensor as is right to the axle, because you usually got about 6 inches of suspension travel on most cars, and it'll work just fine. Now, if you mount this sensor to an independent front end or an independent rear, and you're mounting to the lower control arm, remember we were talking about spring rate earlier, you got a motion ratio there. So you might have 6 inches of wheel travel, but where you're mounting that sensor to the lower arm, there might only be 2 or 3 inches of travel there. So to get enough resolution out of this sensor, what we'll need to do is just drill another hole a little bit further in here to where you actually get enough swing out of the sensor. Like I said, you can watch this, you can mock it up the first time and then run the suspension through its travel on a floor jack and see where it's swinging. So no, not the sensor. It doesn't make any difference. And as long as it's staying within its range of travel, it doesn't have to be perfect, because it's after you get it mounted, you'll run through a calibration sequence, and then that's when you'll actually set where at in that suspension, in that voltage swing is your ride height and your deflated and your inflated. So it's just giving a reference point. Shocks. We've spent the last 3 years of our company working on shock absorber technology and refining our shock absorber technology. We've went through several different shock manufacturers over the years, and never quite found the level of performance and durability that we were looking for. And a few years back, we actually got teamed up with Fox Racing on a military project we were working on. And then they were kind enough to go ahead and build us a hot rod shock, something with the proper travel and the proper valving for the vehicles that we work on. So We now use Fox shock absorbers on all of our suspension systems, coilovers, shock waves, air suspension, standalone shocks. All of our shocks are manufactured by Fox Racing. One of the things I learned when you start looking into shock absorbers, and you can take all the brand names off the shocks, take all the stickers off of them, there's two basic types of shocks that you're going to find out there. You're going to see a monotube shock and a twin tube shock. Twin tube shocks is what we had used up until about 3 years ago. It's pretty much all that was available in this industry. Monotube shocks are much newer technology. You were talking quite a bit of money to get into a monotube shock of decent quality. The pistons are much bigger, the shim stacks are much bigger. Newer technology that hasn't been through 50 years of cost reductions. So Fox Racing is probably one of the only manufacturers out there that builds enough monotube shocks, be it the mountain bike industry, the off-road industry, OE, a lot of the new Ford Raptor pickups, you'll see they all have the Fox shocks on it, and several other, and definitely off-road, Baja trucks, everything. Four-wheelers, side-by-side, snowmobiles. I'm sure a lot of you guys ride some snowmobiles up here with some Fox shocks on it. In my opinion, they make the finest shock absorber out there, and they can do it at a pretty economical price because of how many, the sheer volume of parts that they build a year. When looking at a monotube shock absorber, you have your main piston. I have some cutaways up here you guys can look at later if you want to come up so you can see the actual internal workings of the monotube shock. You have your basic piston here, which has a valve stack on it that and different valve stacks for compression and rebound to change those characteristics for that application. As the piston rod enters the shock, you have to displace some of that oil. So you have a floating piston here, and below that floating piston you have your nitrogen. So that's where it's able to do that. On a twin tube shock absorber, same principle with your inner tube. It has to displace the same volume of the shaft, and it will go down to the bottom of the shock here, changes directions, and comes and goes into your outer tube. And typically you have a nitrogen-filled bag out here to do that. One of the nice things about a mono or a twin tube shock is you can get fairly long travel shock absorbers with a minimal dead length. They're fairly cheap to manufacture. There's a lot of different manufacturers out there building these parts. So. But one of the downsides of a twin tube shock is heat. They build up a lot more heat. You got to remember when you're talking about a shock absorber, the physical, the main goal that we're after when designing a shock, the main goal of a shock absorber is to take kinetic energy, your motion, turn it into heat, and then dissipate that heat. And that's one of the main shortcomings of a twin tube shock. All that heat is going to be built up in the oil here around the piston. You got to remember, as you're driving down the road, the shock isn't going to stroke this much. It's only going to be moving up and down an inch either direction. So all the heat is building up in the oil in that location right there in the middle of the shock. With a twin tube shock, you have the outer tube that's actually insulating from the inner tube. So that actually, especially with the nitrogen there, it just can't dissipate the heat nearly as good as a monotube shock can. And furthermore, a monotube shock doesn't build nearly as much heat because you have a much larger piston diameter. The piston diameter is about twice the size of a twin tube shock. Again, much newer, better technology. We switched about 3 years ago to all monotube shocks, and we saw immediate and definite differences in the ride quality, the performance, the durability of all of our shock absorbers is so much better than it used to be. There's a kind of a cutaway there. You can see the piston here with your different shim stacks. And this is your floating piston, and this is the nitrogen pressure down here. One of the things that I do love about this shock, if you do top out a shock absorber, be it because you hit a big bump or the customer has inflated the car too much and topping the shock out, the piston basically crashes against your rod guides here and can start to cause problems there. Shock starts leaking, beats the seals out of it, blows the top of the shock out. I mean, topping a shock out eventually would destroy it. Fox, with their off-road background, they actually do a rebound stop right here. It's actually an O-ring type rebound stop so that you're not metal-to-metal crashing. These shocks are indestructible. We've tried to drive, we got a C10 truck at the shop that we drove around for about 2 years, topping the shocks out, trying to beat them out, and we could. Did a significant amount of durability testing on shock dynos, trying to destroy these things. Most shock absorbers, especially when you run a shock on a dyno, you're talking about, actually we'll talk about the dyno stuff in a little bit. I got some dyno graphs. Different series of shocks. We have the RQ series, stands for ride quality. This is the customer that isn't as concerned with tuning a shock absorber. He just wants to bolt it on and he wants it to be the correct shock valving out of the box. We have these set up for either independent or straight axle application, depending on the length of the shock. So you don't have to tune the shock. It is ready to go for you out of the box. Most street rods and some of the classic car cruisers, that's the shock series we'll use on those. The next would be the HQ series. This is your handling quality. You can see they actually have a knob here to change the rebound dampening of the shock. The way that rebound dampening works, there's actually, let me go back a couple sides. See this hole here? What that does, it's a simple fixed needle and seat here. Shaft coming down through the shock, needle and seat here. And as you open up that orifice with the needle, it allows oil to bypass the rebound stack. So that way you can make that rebound dampening softer or stiffer. And that is your HQ series shock. And then we come down to the TQ series. TQ series, much like the RQ and HQ, is also impact forged monotube shock absorber. And when they talk about a forged shock, what you do is you start with a slug of aluminum and they beat it out until you have basically your basic shape of the shock body. A forged body is going to be stronger than a straight up machine body. It's just a better way to build the shock. With a lot of the shocks, you actually have a seam down here, and sometimes you see some leaking issues and stuff there too. But the TQ series not only has your rebound dampening up here, just like the HQ series, it's got the remote reservoir, and there's a couple knobs right here in the reservoir for high speed and low speed control of the compression of the shock absorber. What that means, a high speed movement, you're talking 20 inches per second and up, and that's going to be your impact harshness hitting a pothole. Your low speed compression movement is going to be going through corners, 2, 3, 4 inches per second. So what we can do is we can, on a lot of applications like that, we're going to stiffen up the low speed movement to help minimize body roll, but you can keep your high speed compression dampening fairly soft. That way you're not affecting the ride quality as much as well. There's basically a spring and a ball in here that allows it, when you get a high speed impact, that allows it to blow off. And the main change internally on this shock is instead of that floating piston being down here, this is all oil yet, and it moves the floating piston out here. So now that's created us a place that we can restrict that oil flow. Also gives us a lot more oil capacity to help keep oil temperatures lower. It's all about keeping that oil temperature low. If that oil temperature gets too high, then just like brake fade, you can get into shock fade, where the shock actually starts to get weaker and it's not as consistent as it should be. The last series of shock that we offer is the Select series. These are a monotube shock as well. This one we actually make in-house with the help of Delphi, a lot of Delphi technology in this shock. It's an electronically adjustable shock. So by simply pushing a button on the dash, send 12 volts down through the shock, and there's a couple different shim stacks on the piston, so it's changing the flow path of the oil to go through either the firm valve stack or the soft valve stack. These are great for the guy that wants to have great performance and great ride quality, but doesn't want to crawl under the car to adjust the shock absorbers. We build each one of these in-house to order, so we always look at whether it's an independent suspension, straight axle, the weight of the vehicle, and that way we can select the proper soft and firm valve stacks for that application. Coilover systems, again, same shock absorber, just got the coil spring around it, available RQ, HQ, TQ, and Select. Shock waves, same Firestone air spring wrapped around that exact same shock absorber. And when I say the same shock, I mean the same shock, to the point that if you do have a customer that starts out with coilovers and decides he wants to upgrade to air suspension later, we can simply slide that air spring off and slide a coil spring over it. The shock absorbers where the majority of the cost is there. So, and especially with a lot of our muscle car applications, the control arms are the same, the forelinks are the same, the spindles are the same. So there's a lot of interchange there where a guy could go from air suspension to coilovers fairly simply without throwing a lot of parts in the trash. The newest addition to our shock line would be our Q series shocks. This is what we call the Q series, or the smooth body shock absorbers. They are very similar to the coilover shock in design. They are monotube design. They are, instead of a 2-inch body, it's a 1.5-inch diameter body. The necessity for that was for fitting them in OEM applications. If you try to take a 2-inch body, say you have a customer that has a 69 Camaro and he just wants to put better shocks on it. Doesn't want to go through the whole coilover conversion with the control arms and the forelink and all that stuff. Just wants a really good set of shock absorbers to help control some of the floaty feeling of the car and to help the ride quality a little bit. The problem with the 2-inch body is trying to put that 2-inch body through a factory control arm. They won't fit up through the bottom of the arm. So then you would then have to pop the ball joint and the spring apart to get it to install it from the top down. Or you got to hog the control arm out. These shocks are you can actually see a little flat right here on the shock. That's actually there, so it'll fit up through, I think the 69 first-gen Camaros was the smallest hole. It'll actually fit up through a first-gen Camaro. Also help take some cost out of it, since this is just a standard shock absorber, what I call a non-load bearing shock. We do not need, we can get by with a smaller 1/2-inch shaft versus the 5/8 shaft. And you can use poly bushings in it versus bearings because it's a non-load bearing shock absorber. You don't need the threads on it. So that helped us keep the cost down a little bit on it as well. We have applications for just about anything on those shocks too, so way more than what we even have on our catalog or in our website. You give us the dimensions, compressed, extended dimensions of the shock, what mounting styles you want, we can build just about anything. So, I talked about this a little bit already, so I'll speed through it. The compression and rebound dampening of the shock and what you're adjusting there. Obviously, rebound dampening is the most important to adjust, especially if you're not going to be getting into autocrossing and road course racing. As the suspension compresses, the spring itself is actually what's going to slow down and do most of the work on the compression of the shock. It's all that stored energy of the coil spring coming back up on the rebound. That's the trick. And especially if you're using a 400-pound versus a 600-pound spring, that's going to take a significantly different amount of rebound dampening to control that. So. Most of our shocks have about 24 clicks to it. The number of clicks doesn't always dictate how much you're adjusting the shock either. You can we've dynoed some shocks in the past that might have 20 or 30 clicks to them, but the graph doesn't move that much, so that the number of clicks doesn't tell you how much you're adjusting the shock absorber. Our shocks, we set them up, they have and you can, with the needle and seat and your orifice size, you can change how much that actually adjusts the shock absorber per click. So we've opened that up quite a bit. So from full soft to full compression, you're going to feel a lot of difference there. I've had some shocks in the past on my Chevelle that you click them, and you just don't really feel the difference at the wheel, With these shocks, you'll very soon get to the point where you're like, that's too much. I need to back it back down. So, again, there is a wide range of adjustment on it. You can see on a dynograph like this, what you're looking at is this is your velocity, your inches per second. And then this is the amount of force being applied to it. So, this shock, you're going from 300, it's kind of hard to read and fuzzy, from 300 to about 525 pounds at 10 inches per second. And compression adjustments, like I said, we actually have knobs on the reservoir now, high speed and low speed knobs on it, turn it by hand. And that's what a triple adjustable dynograph looks like. One thing you really look for, and that I take for granted sometimes, is the consistency in the dynagraphs on the Fox shock absorber with the precision ground pistons and shims. You get a very even line, and it's not a real drastic up and down difference. It's a very, very tunable and very repeatable shock absorber. Good performance. How to measure your shocks. We talked about this a little bit earlier. Obviously, you want to measure from on a rear suspension like this, from your upper shock mount to your lower shock mount at ride height. If you have an adjustable lower mount like this, you, like I said, I would usually go to the bottom hole, and we have these little built aluminum blocks here that we manufacture as well, that it drops your bottom hole in the block about 1.25 inches below the bottom hole on the axle. A lot of cars that were designed with a very short ride height, this allows us to get to the next length longer shock absorber. When it comes to ride quality, it's all about shock travel. The more shock travel, the better. Sometimes easier said than done, especially when you're building a fairly low car and you're trying to stay under without cutting the floor pan and trunk pan and stuff like that. But make sure you have enough compression travel. Like as we were talking earlier, you want at least 3 inches of compression travel and 2 inches of rebound travel. It's 5 inches of total travel. You can get by with less. 4 inches of suspension travel, you can get a good ride quality out of it, but your margin of error is pretty small on that. You got to have it set exactly at that 60% stroke to get by with bottoming out or compressing. Or you end up running a much higher spring rate than what's really needed for that car to keep it from bottoming out. So we've got all kinds of different length shocks available for the car, anywhere from 2.5-inch stroke up to 6.9-inch stroke shocks. Spring rates, we have hundreds of different springs on the shelf available. Mounting hardware. With all of our coilover systems, we actually send different spacers here to allow you to go from a 1/2-inch bolt to a 5/8 bolt on either end of it. They actually use a 5/8 Teflon line bearing in all the shocks. Like I was stating earlier, when you have a load bearing shock like that, we've tried using polyurethane bushings over the years and rubber and everything else. But on a load bearing shock like that, you just don't get the durability out of a polyurethane shock that you will. And if you get the durometer of the bushing hard enough to where it can handle the amount of force you put on it, then it starts to side load the shock a little bit. With a rear suspension, you can probably get away with it, but especially with the front, you got to remember, if you got 1,000 pounds of the wheel, there's 2,000 pounds pushing down on those bushings. So on all load bearing shocks, be it a shockwave or a coilover, we use bearings. On all standalone shock absorbers, we will use a polyurethane or rubber bushing. We also use stud type mounts on some applications, especially front applications when we're going to the factory shock mount. We designed this instead of, again, polyurethane bushings there don't last very long. They usually squish out. So this is a Delrin ball and socket design. Delrin's a material, kind of a plastic type material. We get it with about 13% Teflon in it. The added Teflon in there gives it a lot of lubricity, so it doesn't seize up or anything like that. I think I'm getting short on time here. I'll have to speed up. That ensures you don't get any side loading on the shock. Side loading a shock can prematurely wear out the seals. So with this design, with this ball and socket design here, it's ensuring that you're always pushing straight down on the shaft and you're not side loading the shaft. And there is your Kevlar line mounts. We have different length eye mounts as well as stud mounts available. So if you end up needing some extra clearance on certain applications, we can always use different length eye mounts in it. And this is probably the best thing with our shocks is the warranty. We launched this warranty right at a year ago. This warranty, 1,000,001 mile warranty, I think speaks volumes with our shock absorbers and how good we feel about it. After 3 years going on now selling these shocks, we've had almost 0 failures. I mean, they last forever. It is the best shock absorber on the market. Air suspension options. Yes, sir.
Just, you said if you do see failure, where is it?
Honestly, a lot of times we don't have the vehicle there, so it's hard to tell if something's installer error or not. But I shouldn't have even said it that way. I misspoke there, I guess. The question was about failures, and if we do see a failure, where is it at? Usually on the shaft guide, when a shock like that, especially if you see us where the shaft is actually bent, then we know that that there's an installation error somewhere and that there's a serious side load on the shock absorber. For example, on a straight axle rear suspension, we'll typically mount the shocks in about 20 degrees. I've seen guys mount it with the mounting bolts going left to right in the car versus front to back. Well, then as the car moves up and down, it's trying to bend the shock in half instead of rotate on the bolt. So it's usually something like that. There's a lot of companies out there that offer free rebuilds on shock absorbers. I'm not going to rebuild it. We see almost no failures on a shock. So my goal in choosing a shock manufacturer was a shock that doesn't fail, not one that we need to rebuild for free. You know, I don't ever want to see these shocks back, and I'm sure you guys don't ever want to see a leaking shock either. So that is something I can guarantee you'll never see is one of these shocks leaking. With our dyno tests on it, we tested a lot of different shock manufacturers, again, about 4 or 5 years ago when we were looking into different shock manufacturers. And most of the shocks, when you start talking about inches per second, we run them on the dyno for about 15 minutes. A good pothole, you're looking 35, 40 inches per second. A lot of the shocks were starting to leak around that. You know, if you run them a long enough time at that speed, we're starting to leak about 40, 45 inches per second. Even the really good shock manufacturers we were testing were, especially if you run them long enough, especially twin tube shocks because they hold so much more heat, would start heating the seals up to the point where they'd start leaking oil out the shaft and stuff around 75 inches per second. We tapped out the dyno at 100 inches per second with this shock and no problems whatsoever. So we had to call our friends at Fox because they're the only ones with a dyno big enough that I'm aware of to run it up high enough with their off-road stuff they do. They'll see, in some of those shocks, they'll see upwards of 300 inches per second. So, and that's continuous duty. But this shock, they guarantee it to 200 inches per second. So that's 4 times more than any other shock we had tested. So we're confident with that warranty. And why we can stand behind that warranty is I know we won't have any problems with it. 3 years and probably 30 or 40,000 shocks later, and I've seen like literally 2 or 3 shocks come back that were leaking oil due to a manufacturing error on those couple. But anyways, yes, I know. Let me just flip through this real quick. All of our control arms we manufacture in-house. Bolt-in 4-link systems we manufacture in-house. Universal weld-in 4-links. Sway bars. And we now do tiger cages as well. It's a full bolt-in roll cage system, all stainless steel.